Hey guys, and welcome to part 2 of the lottery contract tutorial series. If you haven't seen part 1 yet, I highly recommend pausing this video and going back and checking that out first before continuing here, just so you have some context around what we'll be working on in this video. The focus of this tutorial will be to use the Chainlink decentralized Oracle network to generate a truly verifiable random number for our smart contract choose winner algorithm. And we'll use this to replace our previous pseudo-random number generator function that we put in place in part 1. So if that sounds good, stick around and let's get to work on our new and improved lottery contract. See you in a bit. So as we mentioned in the first video, getting a random number in Solidity is a big challenge. That's because Solidity doesn't have any out-of-the-box random number generator code. Also, the blockchain and computers in general are deterministic in nature, which means that any future state is predictable given knowledge of past or current states of the system. Enter Chainlink. Chainlink is a decentralized Oracle network. What exactly is an oracle in the blockchain world? Well, an oracle is a service that connects a blockchain with the outside world, or off-chain data sources and services. It should provide a secure way for data to be transferred on and off the blockchain. One of the problems that an oracle poses is that it introduces a point of centralization into the decentralized blockchain. This could potentially introduce corruption into the system via man-in-the-middle attacks or manipulation of data by those who are running the oracle itself. One proposed solution to these problems is to decentralize the oracle itself. Chainlink is one such decentralized oracle. In this lesson, we'll be using the Chainlink VRF, or verifiable random function service, in order to generate a truly and verifiably random number for our lottery contract. So let's set up a new contract that generates a random number via Chainlink. And once that's working, we'll figure out how to integrate that code into our lottery contract and use it to replace the pseudo-random number code that we put into place in the previous tutorial. So if we take a look at the Chainlink VRF documentation, we can click on this link here, get a random number. And this is described in great detail, and they actually provide the code, all of the code that you would need to request and receive a random number. So at this point, we could just copy and paste this code. In fact, you can open it directly into Remix. But I think what we're going to do in this video is we're just going to go ahead and write it out line by line so we can really study it and go over each line and make sure that we have a thorough understanding of what each line is doing. It's not much code, so let's go ahead and tackle that next. All right, so I'm back in my Remix editor where we left off after coding our first lottery contract. Now what I'm going to do is I'm going to go under contracts and rename one of the sample contracts so we can work on it for our random number generator. So I'm going to take number 2, owner, and let's just call it random number for now. Okay, and we can go ahead and delete all the code in the existing file. Okay, so I'll start out with my license identifier. And we'll give it a Solidity version, so I'm going to say pragma Solidity 0.8.11. Next, let's go ahead and define a contract. And we'll call it random number and give it some curly braces. All right, so the next thing we're going to want to do is to import the Chainlink code so that we have access to the Chainlink VRF in our smart contract. So I'm going to go on over to the code sample and copy and paste the import statement right here. And I will link this page in the description of the video so that you guys have it for easy access. I'm going to paste that right underneath our pragma Solidity statement here. Now, what we're going to do is to use inheritance so that our contract actually inherits this contract from Chainlink. So the way we can do that in Solidity, we'll first copy the contract name, and then we'll say contract random number is VRF consumer base. And that is basically how inheritance is done in Solidity. All right, so the next thing I want to do is to define some state variables. So the first variable we're going to need is a bytes 32 internal variable called key hash. Okay, so this basically identifies which Chainlink oracle to use. And we can find this information in the Chainlink docs. So we will fill that in just a little bit. Okay. The next variable is going to be a uint, also internal, called fee. Now, much like executing functions on the Ethereum blockchain requires Ether, invoking functions from Chainlink requires link. So link is the Chainlink token, and we'll have to make sure that our contract is supplied with enough link to request these random numbers. Okay. Now finally, we'll just need a placeholder for the random number result. So I'll do another uint. This one could be public, and we'll call it random result. Okay, great. So we've got our three state variables. Now let's go ahead and define a constructor. So I'll use our constructor keyword. Okay. Now, since we're inheriting from another contract, we'll actually have to call its constructor inside of our constructor. Okay, so I'll give this guy some curly braces. Now, what we're going to do is call the VRF consumer base constructor and pass in the VRF coordinator and the link token defined above. Okay, so let's give some space here because some of these variables values are going to be quite long. So what we can do is we can find this information in the Chainlink documentation. And let's see, I've got the links right here. And again, I'll add these links in the video description. Okay, so when we do our testing, we're actually going to be using the Rinkeby testnet Ethereum test network. So there are specific values for each network, for mainnet and for each of the test networks. So let's scroll down until we find Ethereum Rinkeby. Here we go. So the first value that we need to pass into that constructor is the VRF coordinator right here. So this value should be the same for all of our smart contracts when we're using Rinkeby. Okay, so let's go back over here. We'll go ahead and paste that value here, and then we'll do a comma separated list here. Well, first I'll comment this VRF coordinator. Okay, and basically what this is, the VRF coordinator, that is the address of the smart contract that verifies the randomness of the number returned by Chainlink. So it verifies that it is a truly random number. All right, the next thing we're going to need is the link token. In other words, the address to the link token on Rinkeby testnet. Okay, so we can also find that back here, right here under link. So let's go ahead and grab that value. And we'll paste that right here as the second argument. Whoops, way too many spaces there. Okay, and I'll just tidy this up a bit. All right, so in the function body, we'll define the key hash, or sorry, we'll set the key hash as well as the fee. All right, so we should be able to find these things as well on this page. So let's go ahead and copy that key hash value in there. Okay, and this is not a string, so we don't need quotes here. And the fee, we'll grab that as well. Now the fee is 0.1/10 of a link. So the way we'll actually need to express that in way, so we can do 0.1 times 10 and 18 decimal places. All right, 0.1 link. So this fee may vary depending on the network that we're using. So that's why it's always important to check the values here on this page here, VRF contracts. All right, so finally we've just got two functions to write. The first one is get random number, and then the second one is going to be fulfill randomness, which is a callback function used by the VRF consumer base after that random number has been attained. All right, so let's do our first one. We'll say function get random number. It's going to be a public function, and it's going to return a bytes 32 request ID. Okay. And inside the function body, we have one require statement just to make sure that the contract has enough link to execute the request. So we'll say require link dot balance of contract address, which is address this, is greater than or equal to the fee. And if that check fails, we'll say not enough link in contract. Okay, and on the next line, we'll finally return our actual request for the random number. So we'll say return request randomness, and that function is going to take two arguments. First one is the key hash, and the second one is the fee, both which we've already defined. Okay, and that is all we have to do for get random number. Now we move on to the next and final function of this smart contract, which is going to be the fulfill randomness function. So I'll say function fulfill randomness, and make sure I spelled that right. Okay, looks good. Now again, this function acts as a callback that the Chainlink code is going to use, so we don't actually have to invoke it from our smart contract directly. Okay, this is going to take two arguments, a bytes 32 request ID from the above function return statement. So we'll say request ID, and the second is going to be a uint randomness. This is going to be an internal function, an override, meaning it's overriding a function of the same name from the VRF consumer base. And finally, we're going to populate the state variable that we defined at the very beginning, random result. Okay, so I'll say random result equals randomness. All right, and with that, our smart contract is complete. So let's go ahead and do some testing now. All right, so before we deploy and test our code, we're going to do a little bit of setup. We're going to need to make sure that we have, first of all, MetaMask installed. So if you guys don't know how to install MetaMask, or if you've never done it before, I highly suggest you take a look at one of my previous videos, Smart Contract Testing and Deployment Guide. This goes through the steps on how to install MetaMask. Or you can just Google it, and honestly, it's really simple. You could probably just, it's like a one-click install, honestly. So I'm not going to go through that here since I already have MetaMask set up on my computer. But the first thing you're going to need to do is make sure you have some test ether for the Rinkeby test network. So when you first open MetaMask, it probably defaults to mainnet. So you may need to toggle this show hide test networks right here. Okay, and then flip over to Rinkeby test network. And you're going to want to make sure you have a couple of ether for testing. So if you don't have any, there is a faucet application that hopefully is working. It was actually down a little bit earlier today. This should be it right here, authenticated faucet. Yeah, there we go. So it looks like it's back up. That's good news. Again, I'm not going to go through this directly here, but you can find out how to do this in my smart contract testing and deployment guide. I go through step by step how to work with this faucet here. But basically, you'll need to have some sort of social network URL like Twitter or Facebook. You'll have to create a temporary post with the account number from your MetaMask wallet that you want the the test ether to be sent to. So in other words, I would copy this, I would go out to Twitter, I would make a post with just this account number, and then I would grab a link to that post, and that's what I would put here into this. You can see my history. I've got like twitter.com, blah, blah, blah. And then click on Give Me Ether. And I suggest just going for the 18.75. That means you'll be blacklisted for 3 days, but that's okay because this should give you plenty to work with, okay? So once you've done that, once you have some Ether to work with, then the next thing we'll need to do is get some link tokens. Okay, and I'll add this link to the description of the video, but this page should give us, here it is, a link to our link faucet. That's too many links for one sentence, but you get the idea. All right, so once we come here, make sure the correct network is selected. So we'll say Ethereum Rinkeby, and I'll go ahead and go through this one because I do want to add some more link to my account. So I'll copy my address, I'll paste it in here. 10 test link, yep, that sounds good. Oh, it'll also give us a little bit of Ether, but we should get 18 from the Rinkeby faucet, so that'll be a lot better. Okay, send request. Great, so this will take maybe a few seconds to a few minutes to go ahead and confirm. Tokens transferred. So let's go and see how that we can view our link balance in MetaMask. So I'm going to pop open MetaMask here, and I'm going to go over to the Assets tab, and then I'm going to scroll down here to Import Tokens. Okay, then, okay, good, it's on Custom Tokens. What I need to do is paste in the token contract, which we can get from our code actually, because we used it before. Right here. So go ahead and grab the link token address. So again, this is the address to the link smart contract on Rinkeby. And where'd my wallet go? Whoops. It closes if you switch over to a browser. So again, I'm going to go to import tokens. I'm going to paste that here, and there we go. It recognizes it as link. And I'm going to go ahead and click on add custom token. And looks like I've got 18 link, so I'm going to click import tokens, and there we go. Now this should show up on my home screen right next to my Ether. All right, so I've got enough Ether to work with, I've got enough link to work with, and let's proceed to testing now. All right, so I'm back over in my Remix editor, and let's figure out how to deploy this contract so we can start calling some methods on it and see if we can't get a verifiably random generated number. So let's see, I'm going to click on the second tab from the top. No, I'm not. I'm going to click on the third tab from the top with the Ethereum icon here. Now, in previous tutorials, we've always deployed to the JavaScript virtual blockchain. This time, we're going to select Injected Web 3. Now, what this means is that we'll actually be working through our MetaMask wallet with our real accounts rather than the auto-generated accounts that the virtual blockchain provides for us. All right, so it's asking us to connect, so we'll go through next, connect, and we're basically signing a transaction to agree to connect to Remix. All right, so once we've done that, let's make sure our contract is compiled. So I'm going to click on compile here. Oops, and got an error. Expected semicolon, but got identifier. What doesn't it like here? We've made some kind of mistake. I've made some kind of mistake. Bytes 32 internal key hash. Usually this is a spelling thing. VRF consumer base, internal fee, random result. What does it say again? Key hash? Identifies which chain link. Parser error. So I'm not sure what it... Can you guys identify the error here that I've made? Internal. It's probably a spelling thing somewhere. Aha. And I misspelled it twice. I must have one finger that's not working or something. All right, let's try that again. Let's go ahead and compile. Okay, we'll see how useful this is. You know, it's finding all my mistakes. Expected semicolon, but got... Let's see. Expecting semicolon, but got... Oh, I think I've got one too many brackets here. Let's see. Is that right? Get rid of this one. Control save. Yeah, because I was thinking that this would be nested, but this is just a syntax thing. It's like constructor and then call the VRF consumer-based constructor right after that, and then one set of curly braces for both of them. So sorry about that, my mistake. And was that successful? Let's go ahead and try to deploy our contract. So notice that it's identified Rinkeby because it's reading that from our MetaMask wallet. So it knows which network that we're targeting. Let's go ahead and click on deploy. The contract may be abstract, not implemented in an abstract parent's methods completely, or not invoke an inherited contract's constructor correctly. Seems like I've seen this error before. What could I be doing wrong here? Let's see, I'm still looking at that constructor. That looks correct to me. Let's take a look at the sample code from Chainlink. And let's just sort of compare with what we've got. Let's see, how do they form their constructor? Yeah, I think that's correct. I'll tell you what we can do. Let's open from Remix directly from Chainlink and see what their remix looks like compared to ours. Must have gone wrong somewhere, so let's see. Oh, I wonder if, you know what? No, version 8, that looks correct. That's exactly the same. Here of consumer base. Sorry, I hope you guys aren't getting dizzy here. I'm just going back and forth and verifying. I don't know, it looks the same to me. Let me, oh, okay. I've got the wrong contract selected. What I want is, see, it's auto-populating this with all my inherited code from Chainlink. What I really want is the last one here. I think that's the problem. Let's try that again. Yeah, this is a good sign that MetaMask is opening because it's going to ask us to confirm the gas fees for deployment. Because remember, this time we're deploying to Rinkeby. When we deployed to our JavaScript virtual environment, we didn't have to pay those gas fees. Or it was taken care of behind the scenes, I think is actually the case. So we got our success message. Let's go down and let's open up our code here. This is our deployed contract. So first let's check random result. It should be 0. Okay. Now, moment of truth, let's check our get random number. Gas estimation errored with the following message. The transaction execution will likely fail. Do you want to force sending? Not enough link in contract. Ah, okay. That's actually good. I'm glad we went through this because we missed one vital step, or I missed one vital step. What we need to do is send some link from our MetaMask wallet to our deployed contract. So good news is that's real easy to do. We can come over here and let's copy our contract address. Now let's pop open MetaMask, and we just need to send some link to our contract. So I did the setup, but I forgot to do the most important step. So let's go to send, and let's go ahead and paste that contract address. Now make sure you change the asset to link. Okay, and I'm gonna, let's send to link. That should be enough for what we're gonna do here. Okay, and we have to go down and accept the gas fees and confirm the transaction. All right, so that transaction is pending confirmations on the blockchain. That should just take another minute or so. And then what we'll do is we'll come back to Remix and we'll retry our get random number. All right, so it looks like that's gone through now. Let's go back over here and try it again. First, I'm going to clear out our error messages, and I'm just going to open up this console window a little bit bigger here. All right, drum roll, get random number. Okay, again, MetaMask is opening, and it's going to ask us to accept or confirm the gas fees. Go ahead and click on confirm. All right, now sometimes this takes a while, so we've got a success message. Let's check our random result. That means that the transaction's been sent, but it doesn't necessarily mean that that number's been determined and that our callback has been called. So remember, we're invoking this function directly, right? So this is going to invoke the function out at Chainlink VRF. That's going to get our randomly generated number, and then it's going to do a callback to fulfill randomness. Okay, so we won't really know when this has happened until we check this variable. So let's check it now. Yeah, see, it's still 0, so we're actually still waiting for this random number to be generated and returned and the callback invoked. All right, let's try that again. Still 0. This is taking a while. So, you know, I've read that some people are critical of Chainlink's VRF function because it takes so long. And, you know, I think it just matters. I think it just depends on how you want to use it. You know, if this is something that needs to happen as a response to some user input and you have a user at the UI waiting for this result to come in, yeah, it might not be the best solution. But, you know, in the case of a lottery smart contract, you know, that choose winner function is going to be invoked at some interval, maybe once a week, something like that. It's not like you have anyone waiting for that to happen. You know, that's just going to happen at some pre-specified time. And if it takes a couple of minutes, that's not the end of the world. Really, nobody's going to know the difference. So I think it's still a strong use case to use in our lottery smart contract. All right, it's been another minute or two, so let's check our random result, see if we have anything. There we go. There's our random number. All right, so yeah, like I said, that did take 2 to 3 minutes, I believe. So, you know, if you have a user waiting for a response at the UI level, it might not be a good fit. But with our lottery contract, this is more like a batch job that's going to run, you know, possibly sometime in the middle of the night when nobody's watching. So I think there's still a strong use case for it. All right, so just one more small note. As you can see, the number that was generated is rather large. So let's say we want a specific number, you know, between a specific interval. Well, we can do that. We can go down to our, let's see, randomness right here. And we can use something called a mod function. So let's say we want a number between 1 and 10. We can do mod 10 dot add 1. And that's going to return a random number between 1 and 10. So the mod 10 basically gives us a number between the range of 0 and 9, sort of like an array indexed at 0. And then add 1 just shifts that 1 up, so it's 1 through 10, you know, positive integers. So this is something we can use to sort of mold and shape our random number result. All right, so at this point we've got 2 working contracts. We've tested them both. They both seem to be working just fine. We've got number 1, a lottery contract, and number 2, a random number contract. Now, how are we going to combine these two so that we can use the random number generated in this contract from Chainlink in our initial lottery smart contract? Now, the way I see it, there are 2 possible approaches. We could we could leave these contracts as individual separated contracts, right? And we could have lottery call random number. All right, and this is good for, the reasons of having clean separation of concerns, easier ability to read the code, and things like that. However, when I think about the costs associated with deploying contracts to Ethereum, the last time I deployed a contract, it cost $900. So I'm not sure if I can justify, another additional deployment just to get one random number. So what I'm going to do in this case is I'm actually going to bring the code from random numbers into my lottery contract. Okay, so I'm going to combine the two into one contract. All right, so let's see if we can do that. The first thing I'm going to do is grab my import statement and bring it right here. Okay. Then I'm basically going to copy and paste all my state variables and bring them over next. Okay. Now constructor. What I'm going to do is copy and, well, you know what? I think I can copy and paste the rest from here. What is this? Unused function. Okay, you know what? I'm not going to worry about that for now. I'm going to grab the constructor and the rest of my functions and simply paste them into lottery so I don't have to, do a lot of back and forth here. All right, so those functions are fine. We can leave those as they are. Now we just need to combine these two constructors. So I'll grab the code from here and I'm just going to go ahead and paste it right here. I want to keep a line in between just so I can sort of keep clear in my mind which one is from which contract, but it's not that important. So I'll get rid of this other constructor and there we are. So we've effectively combined both contracts. Now we'll need to update the code so that the lottery contract uses the Chainlink VRF rather than the get random number function that we put in before, which generates a pseudo-random number. So let's find that one first and see what we need to do here. Get random number, yeah. Okay. All right, and we can go ahead and comment this out for the time being. There we go. Now we need to do some refactoring with our pick winner function. So right now we're calling get random number, and then we're proceeding to pay the winner. However, the problem here is that when we call get random number, when we invoke our Chainlink function, we don't know with certainty when the callback is going to be invoked. So we kind of need to split our pick winner into two functions. One to call get random number, and then whenever this callback is invoked, use that random number to then select and pay the winner. So let's see if we can come up with something here. So I'm going to create a new function. I'm going to call it reward winner, or let's just say pay winner. Keep it simple. Pay winner. All right, I'm just going to use public and kind of use some defaults right here because I'm not exactly sure where we're going with this, but what I'm going to do is take the entire body of pick winner and put it into pay winner because I know most of the code is going to have to go down here eventually. Okay. So what I'm going to have to do is invoke get random number from here. Okay, we don't need any arguments, so we'll just copy that and we'll say get random number. Now in our get random number callback, we're going to have to call pay winner. I'm sorry, I'm sorry about that. I meant fulfill randomness. Okay, so we go down below the result. So we're setting the result on this line, and now we need to call pay winner after that so that we have assurance that the random result is set. So we don't need to pass that argument, I don't think. What doesn't it like here? Undeclared identifier, request randomness. And what's this one? Undeclared identifier. Did we miss copying something over? Require So that's just a reference to the link contract balance of. I'm not sure why we're getting that error. We've imported everything. All right, let's not worry about that right now. Okay, so we're going to say pay winner. Inside of pay winner, we're going to already have this random number set as a state variable. So what did we say we called that? Random result. Okay, so now we say random result modulo players.length and on and on. So hopefully this is going to work. All right, so we've divided that function up into two. I think we can totally get rid of this one now. We don't need this anymore. That's our pseudo-random. Whoops. Okay. Expected semicolon, but got. Oh, okay, we're just missing a semicolon here. Control save. All right, so it looks like our contract. Oh, I spoke too soon. Another semicolon. Let's try that again. Oh, and we've still got these two errors. Link and request randomness. So it's not recognizing anything from Chainlink. Ah, okay, so we haven't inherited. That's the problem. So we need to say lottery is, and then copy paste this VRF consumer base. Save it, recompile, and let's see, we just got one more error. Mod is not found or not visible after argument. Oh, well, you know what? I'm not sure why that error is coming, but we don't need this anyway, because we already have the code in place to sort of apply this random number to our players array. So again, we'll save that. We got all kinds of errors and warnings here. You know what? I saw this even when I used the code from Chainlink, so I'm just not going to worry about that warning right now. I think we're in good shape. All right, so we've got our new master smart contract with lottery and random number combined. So let's go ahead and redeploy that and just see if it works, basically. Okay. So we've compiled it. Let's go down to Ethereum icon here, deploy and run transactions. Go ahead and delete, if you haven't already, the previous deployment. Make sure you're on injected web 3, and let's go ahead and deploy again. Oh, make sure your contract is set to 1 lottery. Okay. Go ahead and click deploy. Yep, and we should get our MetaMask pop up here. And we'll go ahead and confirm. Okay. All right, so let's go down to, oh, that took a second, didn't it? All right, now we've got our deployed contract. And we should have all of our methods from lottery and all of our methods from get random number. I'll tell you what, let's just run a couple of these and just make sure stuff's working, kind of do a spot check. Let's do, well, we're not going to do that because it'll take a while. Let's do get balance. Let's just invoke some of the simpler ones, make sure. Okay. Do we have one for the owner? Yeah, I just want to make sure that our constructor is still working. Great, we've got our owner address. Lottery ID, let's check that. It should be 1, right? Because we set it to 1 in the constructor. Let's do get balance. Oh, we did that. It should be 0. Okay, so let's go ahead and try to enter some players into the lottery. So I'll go back up. Oh, we're doing injected web 3, so let's see how we're going to do this. Let's open up MetaMask. All right, so to do this, you're going to have to make sure that you have at least 2 accounts. See, I've got 2 here. If you want to create another one, just do create account. You can use the default name, account 3. Okay, but you know, 2 is the minimum that we need to test our contract. And remember, if you have more than 1 account, you've got to make sure that you send Ether to all the accounts that you're going to use, basically. So my account 3 has 0 Ether, so I'm going to copy the address. I'm going to switch back to account 1. And let's send him like 2 or 3 Ether. I'll say 2. That should be plenty. All right, now I've got 3. Well, shortly I'll have 3 accounts all loaded up with Ether. And we'll just wait for that to go through. All right, so let's enter all 3 of our accounts into the lottery. So the first thing I'm going to do is go back to our little unit converter and grab that value. Okay, I'm going to enter that again into the remix editor under value. And make sure MetaMask is open again. It closes quite often. I don't know if that's probably a security mechanism or something. Oops. All right. Also notice that Remix recognizes that our primary account from MetaMask is selected. So that's reflected here, and I can tell that because it's got 10 Ether. So with that account selected, I'm going to go ahead and do enter. Enter him into the lottery. And of course I'll have to confirm in MetaMask. All right, let's select our second account. Your account is not connected. Okay, go ahead and connect. All right, we've got the connected icon right there. And I'll just verify that by scrolling up a little bit. And yep, we can see that a new account's been selected. So again, I'll grab that value. I'm going to paste it back here. I'm going to scroll back down and I'm going to hit enter again. And we'll confirm that transaction. Okay. And finally, we'll switch to our third account and enter him in as well. Okay, and go ahead and connect. All right, looks like we're connected. And again, I'll grab my value. All right, I'll paste that into here. Scroll back down. Whoops, not that far down. And go ahead and click on enter. Okay, we'll confirm that transaction. Now what we want to do, we want to pick a winner, so let's go ahead and make sure that we've got our primary account selected. All right, great. All right, I'm going to open this window a little bit larger here, and let's go ahead and attempt to pick a winner. I'm going to go ahead and clear the logs, and let's run pick winner. This is going to basically test everything that we've done so far, so fingers crossed here. Oh. Execution reverted, not enough link in contract. That's strange, because didn't we send the contract a bunch of link? Oh, we redeployed, didn't we? That's the reason. Okay, so let's copy this again. See, things take a little bit longer when you're really testing on a real testnet here. So I'm going to do send. You know, it's good for you guys to see these errors because these are kind of common things that happen all the time. And we want to switch to link. And let's go ahead and send to link. That should be enough. And go ahead and confirm that transaction. And we'll wait for that to go through. See, I have an option to speed up if I want to, but that's going to spend more Ether, so we'll wait. We've spent a lot already. Good thing it's just test Ether. There we go. Okay, let's try this again. So again, make sure you're on account number 1, or whatever account you use to deploy your smart contract. And let's try pick winner one more time. Always a good sign when MetaMask pops up. We've gotten that far at least, so let's go ahead and confirm that. Now remember, this may take a few minutes because, when we tested our random number from Chainlink, that took like a good 2 or 3 minutes. So we'll pause here and we'll come back and hope for the best, and with any luck, we'll have a winner soon. All right, let's see if this has gone through yet. There's a number of ways we can check to see if a winner's been chosen. First of all, we can check get players. So that's 0, so I think that's a good sign. That could mean that, execution's completed and we've reset our lottery. We can do get balance. That's also 0, indicating a possible reset. We can check the lottery ID, see if it's been incremented. 2, that's good. We can check our random result, and that's been populated as well. So let's see, what else can we do? Where's our, get winner by lottery ID. So let's check the winner for lottery number 1. And there we have it. So 0x8A9, and let's see if we can find that in MetaMask just to cross-check. That's, no, not that one. Check number 2. Not that one, so it must be number 3. Yep, there we go. 0x8A9 matches up with our winner here. So account number 3 is the winner, and everything seems to be working great. So we've successfully integrated our Chainlink VRF with our initial lottery contract. So we've improved our contract, and now we have a real, truly verifiable random number being used. So guys, that concludes this tutorial. That is all that I wanted to cover. I know that it was a lot, so hopefully it wasn't too painful getting through some of the tougher spots, but I think it's helpful to see kind of the process and to see some of the errors pop up and see a little bit of the troubleshooting that you might go on that you might encounter while developing smart contracts. So hopefully this was helpful and interesting, and thanks for watching again, and hope to see you guys in the next one. All right, guys, take care. Bye-bye.